So I have these 10 volt 1000 microfarad capacitors. Those are pathetic. This is what I want. 10 volt 100,000 microfarad. It says 3" by 6" can. I mean, these are tiny. That's only like, what, 5/8 of an inch? Maybe about 3/4 of an inch long. I think we're going to get 2 of these and see how they compare to a 9 volt battery, because I've been doing these really unsafe experiments with my meter and my toaster and my hand crank generator and capacitor bank. The other day I wired my capacitor bank into a series parallel circuit like that. You got 2 capacitors in series and then they go in parallel like that. I have 2 banks of positive and I have 2 banks of negative right here, and they're split right down the center like that. I have this series parallel circuit and this series parallel circuit wired together with these wires here. Negative to negative, positive to positive, just like that. I have equal amounts of power on both sides of these. So anyway, why do we have it in 2 equally sized banks? Because we want to make alternating current. This is how alternating current is made. In this picture, this is showing batteries, but we're using capacitors instead of batteries. Basically, you have this end, you have positive here, negative here, and they're connected like that. There's your load, that would be my toaster. And here's your 3-way switch, switching it from negative to positive, negative to positive. You'd have a heck of a time flipping that switch back and forth to get 60 Hertz. In the United States, we use 60 Hertz electricity, which means it switches from positive to negative 60 times a second. They just use 60 times a second so they can coordinate the power plants in the United States to the atomic clock, and I think it's in Colorado, so that all the frequency in this country is matched. You can also do this with 2 NPN transistors or 2 IGBTs, integrated gate bipolar transistors. This right here is what an IGBT looks like, integrated gate bipolar transistor. This is a 150 amp 1200 volt transistor. If you had 2 of these, you could run your house if you had a powerful enough DC source. Right here I have a better picture of one of these things. These things are about 6 to 8 inches across. And when you do buy these, you have to get special screws for these. These only take one type of screw. You can't just go and stick a steel screw in there because it'll rust, since this is DC going into this thing and coming out of it. I have collector 1, emitter 2, collector 2, and emitter 1. Over here, these are what controls your gates on your transistors. And down here you can see the circuit, how it is. It's also got diodes built in, just like that. You can see how it is. Yeah, this DC to AC stuff is the future. I'm telling you, you gotta watch buying some of this stuff on here, because right after you get it, you may get a phone call saying, why did you buy that? What do you plan to use it for? Are you gonna take it out of the country? You'll get a phone call like that on some of this stuff. I only had that happen to me one time when I bought a capacitor. Right here we have our 3-way light switch. You got your common, and you got your 2 traveler screws, just like that, that go to your traveler wires. We have the common coming over here, going through this meter, and to the output there, which goes to the toaster. This end of the output going to here, and this wire comes over here to this end, and this other red wire comes over here and goes to this end. And then we have our traveler wires going up to here through this transformer into the capacitor bank like that. You got negative going to the green wire and positive going to the red wire. And it goes to the black traveler wire here. One of the experiments we've been doing is one where we have our positive flowing through the transformer into the load. And when it's doing that, it's inducing a current into this green wire, which this green wire comes over here and charges this half. So when I'm using this half of the capacitors, it's charging that half. And because of the inductance in the transformer, it causes a small power surge that compensates for any voltage loss through the load. Okay, we take our hand crank generator, we charge up this half of the capacitors, and what we do is we flick this switch, positive flows through here, goes through the transformer, through the switch, through this meter, through these meters, into the load. As it's doing that, it's inducing a current flow into the second coil. And this second coil comes over here and charges this. And then when you don't have any more power on this side, you flick the switch this way and you pull power from this side. But you're not actually pulling power from the negative, because current flows from positive to negative. You're actually pulling positive from that side, and it's going right to your load like that. Your positive current is actually flowing this way through the switch, back up here and back to negative. And as it's doing that, you're inducing current into this coil and it's recharging this side. Yeah, you want a transformer with 2 equally sized coils. I tell you, this is the kind of work I live for. Well, thanks for watching. Please subscribe. Remember, always be creative.